Okay, so here we will have this equation. The equation is C rho del u del t equal to del x k naught del u del x plus q. Okay, so in here, for the at first k naught is in terms of x. Okay, I think I mentioned earlier. So if k naught is in terms of x, since here is the derivative with respect to x, means it has to stay inside here. Okay, but for the our scope here, okay, is okay. I write down here. We will consider okay the c rho and k. Okay, previously at the beginning we say c is in terms of x, rho is in terms of x. That is the general one. K not also in terms of x. Okay, we will consider c rho and k naught as constant. Okay, for the at first we consider this is the general case. If you find other sources in the maybe in the advanced level, there is a heat equation that consists of C rho k naught in terms of x function. Okay, but for our scope here, for this course, we will consider C rho and k naught as a constant, means it does not depend on x. It is not in terms of x. Okay, it is just a number for C rho and k naught. So means if we consider it as a constant on the right here, a constant here, we can bring it up from the derivative. Okay, so we will get now 0 del u del t equal to k naught del square u del x square plus q. Okay, so now we will obtain the heat equation. If I divide with 0 here, we have the equation del u del t equal to k naught over 0 del square u del x square. Okay, del here. Okay, here is del. Okay, plus q over 0. Okay, so in this case, k naught over 0 is the constant. Okay, so physically k naught over 0 is constant now, known as the if I'm not mistaken, it is the thermal diffusivity. Okay, so after step 3, this is how the equation looks like. Okay, if we consider there is a heat source, okay, the term here still appear q over 0. Okay, remember the form of the heat equation that we learned in our previous lecture in solving the heat equation using method of separation of variable. It is in this form. It consists of these two terms only. Okay, so actually for our scope, we will consider if there is no source, if there is no source, means we have the term q is equal to 0. Okay, no source, or the physical words that reflect this term is sometimes we call it no source, or we say no heat generated inside the rod, and so on. Okay, so means Q equal to 0. So from this equation, we will get del U del T equal to K naught over 0 del square U del X square. Okay, so this is the heat equation that we have seen in the previous lecture. We see the method of separation of variable. We solve the heat equation. We use maybe quite different, a bit different like this. We have okay, we see previously C or K. I don't remember K or C here. Okay, so if you see on the right, K actually represent the K naught over 0, which is the thermal diffusivity. Okay, so that is the heat equation. Where in this equation, we have one dependent variable U. U is the temperature. Temperature, we have the independent variable X and T. So heat equation here can be solved using method of separation of variable.